Hello, welcome back. Look at what we're doing. 1.3. Doesn't that sound like fun? Describing quantitative data, that is, numerical data with numbers. So we're going to use numbers to describe numbers. Didn't that sound like fun? Another way you might call this, what we're going to be talking about today are things called summary statistics. Statistics, so a statistic generally is a function of a data set. You put the data set in, it gives you out a statistic. So we're going to be talking about statistics today that summarize the data set, tell you something about kind of the whole data set. So let's get into that with a couple measures of from your SOX thing. You know, when you're talking about shape, outlier, center, and spread. Your first thing here are measures of center. Or central tendency. What is typical? Because that's what measures of central tendency are really trying to get at. It's a quick way to tell a general audience, hey, without showing them a picture of the whole distribution, what's typical? The mean is written as X bar until we start talking about the population mean. So a sample mean is X bar. And you know how to calculate the mean, hopefully. You add them all up and divide by the total. And over here you have something called big sigma notation. That's a capital sigma. And what does that mean? That means add them up, if you're not one of my calculus people, or college algebra. I think maybe you've seen that college algebra. So that's a big sigma. That means add them all up. So what does that say? We're going to add up all the x's, x sub I goes from 1 to n. We're going to add up the n observations. We'll talk about the ith observations. That I down there, that little I down there is called an index. It's like, which one are we talking about? It's like an address or a name tag or something. So we can find the median. We can also find, we can find the mean. We can also find the median. Median, media, that's all come from like the same Latin root, means the middle. The median is the midpoint of a distribution, such that half are smaller and the other half are larger. It's saying, where's the, if I put them in an ordered list, where is the middle of the ordered list? You might write that out to the side. The median is the middle observation in an ordered list, order of size, small to large. If you have an even number, if you have an even number of observations, they're going to be kind of in the middle. Between two data points, you'll find the average of those two values if it's an even case. So we can talk about measures of center and mean and median. Hopefully you don't need a ton of review on. We've got an AP example down below, and we've got to notice for AP examples, newsflash, you can Google search the first line of an AP example, and you're gonna get the scoring guidelines pretty quick. You're not the first people to see this question about pupil-teacher ratios. You saw this question last time, talking about pupil-teacher ratios. We found we described the distribution, SOX. Let's take a read through this. We've got part A, which we didn't do the first time. Sorry for the bells. So once again, it's records of pupil-to-teacher ratios in the 50 states, the 24 west of the Mississippi. So N sub west equals 24. And I'm going to say that N sub E for east is 26, not a G, that's a 6. Great. And describe how we use the histograms to estimate the median pupil-to-teacher ratio for each group of states. Then use the procedure to estimate the median of the West group and the median of the East group. I'm going to make a little thing out to the side here. The median is the n plus 1 over 2 largest observation. How do we find that? We're going to, in a histogram, we're going to add up bin totals until we find the n plus 1 over 2 measurement. or observation. People hate that. So that's our description. We're going to add up bin totals and until we find the n plus 2th observation. So that's, that's the procedure. Where is it going to be? Let's zoom in. What am I talking about? There's 24 measurements over here. So over here for the west, the median will be at the 24 plus 1 over 2 position. So that is 25 over 2 equals, that's 12.5 measurement. So we're looking for the median will be between the 12th and the 13th largest. Where is that? All right, so let's look over here in the west. We have 1 accounted for here. We have a total of 4 accounted for here. All right, well, how many are accounted for up until then? All right, so there's think about this, there's 5 accounted for up until there. All right, and if there are 6 more in this, think about that. We've accounted for 11 of the total measurements. Think about that. 1 is accounted for through here. 4 more makes a total of 5. 6 more makes a total of 11. Here we have 3 more. That means the cumulative total, if we added up how many measurements are accounted for up to here, we've got 11 plus 3, we've accounted for 14. So what does that mean? That means in here, between 15 and 16, that's where the 12.5th measurement is. The 12th largest measurement's in there. The 13th largest measurement is in there. And so necessarily the 12.5 largest measurement, which wasn't a real measurement, lives in there as well. So where's that going to be? That's going to be between 15 and 16 pupils per teacher. Do it again out in the west. Stop, try to do it yourself. See if you can replicate this. Pause for a moment. Or excuse me, in the east. Pause. And now you've done it out in the east. Thank you for pausing. You add up those totals. You say, okay, well, we've accounted for 2 are accounted for there. 2 and 4, okay, that means we've accounted for 6 up through here. We got 4 more. That means we've accounted for 10 up through here. Oh, and my God, that column's got 10 in it, so we've accounted for 20 up through there. Where's that? Same place. 15 and 16. Okay, so in the east we had excuse me, I skipped a step. 26 plus 1 over 2, that's, what is that? It's 27 over 2, that's 13.5. We're looking for the 13.5th position. And once again, that is between 15 and 16 pupils per teacher. As always, you can take a look at the key that I've put on your completed notes. It shows the cumulative frequencies. Cumulative, what does that mean? Cumulative, accumulate, adding up. We are talking about the adding up the totals until we get past, oh, I miscounted on my notes. But the point stands. Let's go back. Almost made a goof there. There are not 10 but 11 measurements in that column. That would make that 21. The point still stands. The 12th and 13th largest measurement would be in there. So we can talk about mean and median. We can compare them. Consider, where would the mean be relative to the median in these distributions? The mean, that's a skewed left distribution. The mean would be greater than the median over here. Over here in this symmetrical distribution, the mean is probably much closer to the median. because of that lack of skew. Remember that skewed distributions pull the mean along with it. Symmetrical-ish distributions don't. All right, so next thing we got to talk about is something called quartiles and the IQR. Quartiles. You may have heard of these. Quartiles should make you think of quarters, should make you think of 4. Dividing the data up into 4 kind of parts. And I just for the first time noticed that there's an error in these notes, and we're going to correct it down here. To calculate the quartiles, arrange the observations in increasing order, locate the median. Okay, this thing called the first quartile is the middle of the values that are less than the median. And the third quartile is the middle of the values that are greater than the median. Okay, so we've got that. When we see the median here is 32, the middle of the bottom of that is 28. The middle of the top of that is 40. We have something called the IQR. It's the distance between those quartiles. The IQR is a measure of spread. It's how spread out is the middle 50% of the distribution. How spread out are things? You might have looked at the IQR of ACT scores at a college you're interested in going to. You say, okay, well, the middle 50% of people at the University of Nebraska are 23 to 27. And you say, great. Fit in right fine there. Okay. So we can find the IQR, first and third quartiles. First quartile, first quarter. How much of the data is less than the first quartile? Well, 1/4, 25%. The median, hopefully less than that, 50%. The third quartile, hopefully less than that, 3/4, 75%. Cool. Let's keep trucking. All right, so you kind of saw on the last page, or at least you saw that they were there on the last page. One of our key, or not key, but maybe simpler summary statistics, one of the simpler ways we could summarize a distribution to someone would be with this thing called the 5-number summary. It's a good kind of summary of a distribution. It doesn't tell you everything, but it tells you, 5 things. What's the smallest value? What's the biggest value? What's the middle? And what are the first and third quartiles? Okay, great. Those things we found on the last page. So great. We have things called outliers, right? We've talked about these before, but up until now we've just kind of used our eyeballs to say, oh, that's an outlier. How do we know? It looks like one. All right, so now we've got actually a real method to find the outliers. It's at least an established procedure using quartiles to identify an outlier. This is better than the eyeball method. Call an observation an outlier if it falls more than 1.5 IQR below the first quartile or above the third quartile. So this is called the 1.5 IQR rule. 1.5 times how spread out the middle 50% is. What's the IQR? How far it is from the first quartile to the third quartile. So we're saying anything that is more than 1.5 of those away, 1.5 of those away in either direction, we're saying that's beyond that is an outlier. Okay, how do we come up with that? It's an arbitrary thing. How do we find these low outlier cutoffs and high outlier cutoffs? Given by those formulas. Q1 minus 1.5 times the IQR, or Q3 plus 1.5 times the IQR. So let's find, let's do a 5-number summary for a data set. This is a little tedious, so let's do it. Let's do it. First, put the data in order. I'm not gonna show me putting the data in order. All right, so I've saved you the rather tedious viewing experience of watching me write down 20 numbers, but there are your 20 numbers. I almost forgot a 15. There's 4 of them, not 3. So go ahead and let's show how we would find these things. The first thing we do is to find and interpret the IQR. We actually first got to find the median. So we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 20 measurements. 20 plus 1 over 2, that's 10.5. So I'm looking for between the 10th and the 11th measurement. That is right here. the median is 22.5. That allows me to find the first quartile, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. There's 10 here, 5 and 5 on either side, so that'll give us a Q1 of 15. We don't have to do any work there. 1, 2, 3, 4, 5 above, 1, 2, 3, 4, 5 from the top, and we get a third quartile of 42 and a half. Okay, so we've got our median, our first and third quartiles. All right, great. So to find the IQR, we would say that's Q3 minus Q1. That's 42 and a half minus 15 is 27.5. What does that mean? What does that mean? It means that the middle 50% of travel times have a range of 27.5 minutes. Cool. Find the mean and median values. We found the median. The median is 22.5. The mean, I don't put in your calculator. All right, so I've got a median 22.5, and you could put this in your calculator, and you're going to find that the mean is 31.25. Okay, just from that relationship, from the fact that the mean is greater than the median, what could you infer from that? You could infer, since the mean is greater than the median, that tells you that this is a skewed right distribution. All right, are there any outliers in the data? Justify your answer. You need to then find the outlier cutoffs. Those are at Q1 minus 1.5 times the IQR, or Q3 plus 1.5 times that IQR. Plugging into those, we get, what is Q1? Q1 is 15 minus 1.5 times, what is that? 27, is that right? Yeah, 27.5. And for Q3, it's 42.5 plus 1.5 times 27.5. Okay, well, you know, you got a calculator. I got a calculator. We can do this. See what it says. What do we got? 1.5 times, what is the IQR? 1.5 times 27.5, that's 41.25. Okay, and I can do the math past that. So 15 minus 41.25, what is that? That's like negative, what, 26.25. Okay, we can't have a negative travel time, so we're not going to have any low outliers. On the positive side, 42 and a half plus 41.25, that's going to be what, 83.5. And so there is one outlier. 85 is an outlier. Neato. So we can do that. And then I'm just going to transition, no cutoffs really, right into this thing called a box plot. And what is a box plot? Box plot is absolutely just a visual representation of that 5-number summary. And it's just placed over a number line. So I'm going to put a little number line here, and I'm going to go 0 up to 100, and I'm going to, I don't know, what can't I? So there's 50, 40, 30, 20, 10, 60, 70, 80, 90. Great, looks beautiful. And I'm just going to put this box plot above the number line. So what is a box plot? It's a graph of the 5-number summary with outliers plotted individually, often with a star or an asterisk. A central box spans the quartiles. So what does that look like? The quartiles are from, all right, so I'm going to label this 10, 20, 30, 40, 50, 60, 70, 80, and 90. The quartiles span from 15 up to 42.5. So that's approximately there. I put a little box there. What is that? That box is where the middle 50% of folks live. I put a line at the median. That's right there at 22.5. I put whiskers to the largest observations that are not the outliers. The lines extend from the box to the smallest and largest observations, not the outliers. So I'm going to plot that outlier up here at 85. The biggest thing that's not an outlier, I believe, is 65. So I will put a line at 65, a line at 5, connect that up, and I've got my min, my Q1, my median, my Q3, my max, and my outlier. Why is this nice? It's a good way to say, okay, like middle 50% of people in here. Think each one of these chunks, that's the lowest 25%. That's the second 25%. That's 25 to 50% right there. That's 50 to 75% right there. That's 75 to 100% right there. And the outlier. So now your chance to take a moment to look at an AP example problem with some box plots. You got a couple companies. You need to read through this. In 2009, the starting salary for an entry-level accountant position was $36,000 a year at both corporations. At each corporation, data were collected for 30 employees that were hired as entry-level accountants. So all these folks came in starting at 36,000, and we're still employed by the corporation 5 years later. All right, so we're still there 5 years later. The salaries of those 60 employees are shown below. All right, so you're going to talk about the distributions. It's hard to talk about shape here, but you can talk about center, spread, and outliers. Why is it hard to talk about shape? Because you don't really know with the box plot. It's hard to tell shape from a box plot. I'd put that to the side. That's AP likes to. They don't actually care, but you talk about shape here. And then you have a suppose in part B. Suppose both corporations offered you a job for 36,000 a year as an accountant. Why would you decide to work for A, given the data you're shown? Why would you decide to work for B, given the data you're shown? I'm not going to walk you through this. You need to take a moment to say, hey, what's the center? Median is the obvious one you can see here. What's the spread? You could talk about IQR or range. It doesn't matter. And you can speak to the outliers, which are apparent on the graph. Part A, looking for like 3 sentences here, describing the center, spread, and outliers. Make sure you have context. Thousands of dollars a year. And then consider why would you choose one or the other. All right, so taking a look at AP's key here. Median salary is approximately the same for both corporations. You had to compare them. Are they greater, less, about the same, whatever. Range and IQR are clearly greater for A than B. The two highest salaries at A are outliers, while corporation B has no outliers. 3 sentences, they talked about the center, spread, and the presence or absence of outliers. All you had to do. Part B, why would you want to work at one company or the other? Why would you want to work at A? Well, you got a potential to make a lot more money at A. The top end is higher at A. I can go to A and I could potentially be making double. Sounds good. Even more than double. That sounds nice, but there's downsides. Why would you accept a job at B? I know I'm going to get a raise at B. Look what could happen at A. You could get no raise at A. You could go through still making 36,000 a day. You're gonna get a raise at B. 100%. You're gonna get a raise. So hopefully you notice that. Take a moment to go back and include that in your key. You might be able to make a higher salary at A than B. Something about that. For part 2, you might not get a raise ever at A. We're gonna get a raise at B. So Next few pages show how to use or how to put a box plot in your calculator. I'll be showing how to do it on my like calculator emulator. Here are the steps. I'm not going to talk through them because I'm going to be sharing my calculator screen, but here they are. Make sure you look through that. If you have a question, look through the dang instructions before you send me an email. Okay, so we're going to create a box plot from this data here. I'm going to just walk you through it. Better Business Council of Large Cities. We got some concluded the city schools, students in the city schools are not learning enough about economics. Great. We've got a random sample of 20 12th grade students. They're going to take a little 46 question multiple choice test and see how they did. 46 questions, and they didn't do very well. All right, so let's look and see how they did. We're going to make a box plot. So let's do it. I'll show you how to make a box plot. Let's get your calculators out. All right, so hopefully you've got your calculator out. I'm going to show this. I hope this is the best view for you. You got key press history. I hope this works for you. So what are we going to do? We're going to go to Stat, hit that Stat button. We're going to edit a list, and we're going to just go ahead and put that list of 20 test scores into list 1. So type it in. It's easier with my keyboard than on your thing. Hope I typed that in right. If I messed one up, you can laugh at me later. I know I've typed in 20 because it says, okay, in list 1, the 21st entry is blank. So I correctly typed in 20, or at least I typed in 20. I don't know if I correctly typed them in because, there you go. So let's take a look. So I'm going to go ahead and second quit out of that. I've got my data in list 1. And now I'm going to go ahead and hit second. And now y equals is going to pull up my stat plot. Great. You've probably never looked at this before. I'm going to turn plot 1 on. What am I making here? I am making this option right here, this 4th option, the box plot with outliers shown. Oop. I need to hit enter on that. Hit enter on that, and then it changes to XList L1. You don't need to change that. That's where your X's are coming from. Frequency, you're not going to touch that. If you want to change what your box or what your outliers look like, you can. It doesn't matter. And then, okay, so plot 1, it's on. We're going to be ready to go. I'm going to second quit out of that. Go into y equals. Make sure that your list is cleared out. Make sure at the bottom of that list you don't have some goofy named thing with some periods and slashes in it that's giving you domain errors or syntax errors. I'm going to quit out of that. Then I'm going to hit zoom. And now at the bottom, you've got something 9, zoom stat. That's going to be a zoom that is customized for the stats that you've put into it or the data that you've put into it. So I do that, and I get, hot dang, I get a box plot. But you're saying, I don't know what any of those numbers are. Go hit that trace button, and the trace button will allow you to bop around the 5-number summary. So take a moment and copy down your box plot, give it some labels on your notes. I'm copying mine on my paper, and I'm gonna make sure to include the numbers below my box plot. So I'm gonna have 8. I know you can't see this, I'll show you in a moment. 13.5, 18, 35.5, and 44. What does that show us? Man, most scores are low. There's a really wide range. Let's flip over. All right, so you copy that over, great. And then it asks, what aspect of shape can't you see from a box plot of the data? Take a look at the data. 8, 9, 10, 14, 16, 17, 18. There are no scores in the 20s. In fact, there's a gap in the data between 18 and 33. There is a gap in the data between 18 and 33 correct. There's a massive gap that we do not see. Are there any outliers? The box plot from the calculator says no, per the calculator. What is the 5-number summary? We've written the 5-number summary above, below the box plot, because the box plot is a visual representation of that 5-number summary. Just a few things left here, I think. Yeah, just a few things left. So down at the bottom, the nasty formula. Yeah, it's here. The standard deviation. What the heck is a standard deviation? It's the average of the squares of the deviations of the observations from their mean. Deviations, deviant, deviations, how far from. The formula is given here. This is going to be on your formula sheet. That is, says add up the value minus the mean, square that distance, divide it by 1 less than the number of observations, and take the square root of the thing. It tells how spread out they are. We also have a thing called variance. Variance is just, s squared. So what is this thing? It tells us the average distance from the mean. About how spread out is the data? How far out are data points going to be from the mean? On average, data points are this far from the mean. Average distance from the mean. Please highlight that. It's a big point. So you've got a formula there. It's given on your notes. It's given on your formula sheet. Not something we have to calculate all that often by hand. It is something that we visually have to observe sometime. Take a look at some dot plots. Rank the standard deviations from least to greatest. I see, okay, well, I'm going to draw some lines here at where I think about the mean is. And which one is the least spread out? So A is the least. Which one's next? Looks like D. Which one's more spread out, C or B? Looks like B is a little more spread out, so I'm going to go with C and then B. So least spread out to most spread out. So great. Looking at the formula, you'll recall that formula from the last page. You might rewrite it. Square root sum xi minus x bar squared over n minus 1. What is this numerator? Add up the distances from the mean. These are going to have the smallest distances from the mean. Here we've got some of the largest distances from the mean. We're going to calculate this exactly once by hand. I think it's kind of a bear. Find and interpret the mean. Let's pause. I'm going to do some calculations. We'll come back to you. This one's kind of tedious, and I don't want to show me writing it out for fear of making a small mistake and having to rewrite it for you. How do we find the mean? You add them up and divide by the total number of measurements. You get an average height on this team of 75 inches. You can calculate the variance by adding, you say, okay, so 67, the data point, minus the mean we found, square it, add up all those squares, you can divide by 4. 5 minus 1 is 4. So the variance is 39, and you get a standard deviation of 6.24. On average, each player is about 6.24 inches from the team's average height. So you follow that formula. It's kind of tedious. I'm not going to have you do it very often, but you do need to understand where the formula comes from. So it's saying how far is it from the mean, adding up all these squared distances, and taking a square root. Why do you think we square it? Why do you think we square the distance from the mean? Why would we do that? So negatives become positive, and so we don't add up some negative. If we added negative things and positive things, we might get 0. We want to add up all those deviations so they don't cancel away. We might also use absolute values, but absolute values make the calculus really gross, is the reason we don't use absolute values and we use squares there. All right, so back to SOX. When the data is skewed or an outlier is present, use the median to compare centers. Skew, we're going to look at the median. If the data is skewed or an outlier is present, we're going to use the IQR to compare the spreads. If the data is symmetrical, you can use the mean or the mode to compare centers, and you can use the standard deviation or variance to compare spreads. You can do these in your calculator using the data in your list. So switching back over, back from the data, remember we have this data put in already. We can go stat, over to calc, 1var stats. Oh, don't even worry about putting anything in for frequency list. You just have list as L1, hit enter. And we get that data from earlier from those test scores. We see the 5-number summary. So going again, stats, calc. If you put the data in 1var stats, it'll pump out that nice summary statistics for you. Mean, median, mode, not mode, but min, max, median, mean, all that business. There you see SX standard deviation. It gives that as well. So very exciting. All right, and now a question for you. Try this on your own. I'll come back and look at the key in a moment, but I got a question about tips. You're going to talk about the tip distribution. SOX, shape, outlier, center, spread. You can see the shape from this one. It's a histogram. And then part B. It says, what if we made one of those $8 tips $18? What's that going to do to the mean? What's that going to do to the median? Think about if this data was an ordered list and you moved that data measure from 8 to 18. How would it affect the mean? How would it affect the median? Pause, think about this for a second. All right, taking a look, it's clearly skewed right. There's a gap. You needed to talk about that gap. If you didn't talk about the gap, go back and talk about it. If you're missing data, you need to mention that. Talk about that gap. There appears to be an outlier. You might make sure you're using that phrase. I'm going to highlight a few things. Highlight. Need to talk about the gap. Need to talk about appearing to be an outlier. Talk about where is the median by saying, okay, add up how many measurements do we have. On that one, you had 60 tip amounts. So your median would be the 30 and the 31st. Yeah, talk about that. What's going to happen to the mean? The mean's going to go, okay, $10 more divided by 60. Think about what happens. You would add 10 to the numerator. Your mean's going to go up about 17 cents. What's going to happen to your median? No change, because the median was below that, and both of those numbers are greater. Think about what happens. You took a number that was already up here in the list. It's already above the median, and now it's even greater than the median. It's not going to affect where the median is. So make sure you've got that. That's the end of my 1.3 notes. It's the end of chapter 1. That's the end of chapter 4. Notes are done. Next time we'll do some FRQ practice.